So to solve a kinematics equation for a fly ball, you already know that the final velocity is 0 meters per second because that's the final velocity when the object is at its highest point, and in this case it's a ball. And we know that the acceleration is negative 10 meters per second squared due to gravity. We found out that the initial position was 1.16 meters using my body as a base estimate for where my bat is when it hits the ball. We also found out that the initial velocity was 49.17 meters per second by using the internet because we couldn't solve how fast a ball leaves the bat. And so we need to solve for final position and time to complete the kinematics equation.
Alright, for the first equation, for time, we're going to use VF minus VI over A equals T. Once you do calculations, you find out that time is 4.92 seconds, and we now know how long it took that specific fly ball to be hit from the batter and hit its highest point in the air.
We also had an equation to solve for XF, which was XI plus 1/2 times VI plus VF times time equals XF. After calculations, we found out that XF equals 121.16 meters. This means how high the ball went at its highest point.
So we already knew that the initial position was 1.16 meters when we measured it using the meter stick. We calculated to find that the final position was 121.16 meters, and we used the internet to find that the initial velocity was 49.17 meters per second, and we already knew that the final velocity was 0 meters per second because that's the final velocity when a ball is at its highest point, or an object. We calculated to find that the time was 4.92 seconds, and we already knew that the acceleration was minus 10 meters per second squared. And that is how a certain type of hit, in this case a fly ball, relates to physics and, more importantly, kinematics.